This is episode 3 of my Gumball Advent Calendar, and it's finally time to address the scariest part of the process, electronics. Part of the inspiration for this project came from watching other videos, including one where a working vending machine was actually built using cardboard, including the coin mechanism. However, this is a silent mode project where copying and pasting is not an option. For full disclosure, I have basic knowledge of electronics and I've built projects from scratch before. The earliest example related to the LEGO hobby was a basic circuit designed to emulate the appearance of Christmas tree lights. I've also built this voting box, which you might have seen at an event, and my most recent project is a remix of a 3D printed Pomodoro timer. Bear in mind that I'm almost completely self-taught and I'm by no means an expert. However, like the projects before this one, it's a valuable learning experience and an opportunity to venture into unknown territory. My platform of choice for the project is the Raspberry Pi Pico W, mostly because I'm familiar with Python. You could probably use an Arduino or an ESP32 board instead. To help with building the circuit that powers the Advent Calendar, I've obtained a copy of Freenov's Ultimate Starter Kit. I highly recommend these kits for anyone looking to get started in electronics, and also as a convenient way to obtain components for experimenting with. You might be thinking, he's going to do this sneaky content creator thing and include an affiliate link.
You damn right!
You can find it in the video description. If you do get one of these kits, I'd recommend getting a larger box to store everything in, because the one provided is packed. In the first episode, I approached the project by breaking it down into smaller parts. This is my strategy for tackling large or difficult tasks, and it greatly helps with avoiding being overwhelmed. I'm doing the same with electronics, and first on the list is perhaps the scariest task of all, controlling a DC motor. You might remember that I'd mentioned using a DC motor instead of a stepper motor. A stepper motor would make more sense if we'd stuck with using a wheel to dispense gifts. They're used when we're concerned about accuracy and with rotating the motor a certain amount. They're commonly used in 3D printers for controlling the axes. Instead, because we're driving a ball lift, we're only concerned about rotating it. What makes the use of motors scary is that they require additional power, more than the Pico can provide. We're using the power module included in the kit to supply power to this DC motor from a 9-volt battery. With guidance from the tutorial, I assembled this first circuit, which demonstrates how the DC motor can be controlled. The blue button turns the motor on and off, and the yellow button changes the direction. With that feat accomplished, let's take a look at the gift dispensing process. If we break it down, it's actually simple. A button is pressed to dispense the gift, which turns the motor on. The motor drives the ball lift, which carries the gifts from the bottom of the machine to the top. Once the gift reaches the top, it begins its exit from the machine. At this point, we should stop the motor. We also want to ensure the gift has left the machine before attempting to dispense another one. I've added a green button to the circuit and updated the logic, so now it acts as follows. The blue button starts the process by enabling the motor. The yellow button tells the machine that a gift has reached the top, so it will stop the motor. The green button tells the machine that the gift has been dispensed and we can start the process again. Note that the buttons must be pressed in order, so a gift can't be dispensed while another is being released. Something I definitely want the machine to have is a display to let the user know what is happening. Included in the Freenov kit is the 16:2 character LCD, which we can use as a starting point. You might be lucky and receive one that includes a backlight. There's another version where the contrast has to be manually adjusted. In any case, the only difference between this stage and the last is the inclusion of this display, which is updated to show what is happening. Let's address our one gift a day rule, which is the main reason we're using electronics instead of trusting someone with coins. To do this, we have to know the time when the last gift was dispensed. For the time being, no pun intended, we'll use the Pico's time as a reference. In this example, there's a 30-second delay between dispensing gifts, during which we'll see a warning if we try. I figured I should add something new, so I've introduced audio feedback with an active buzzer which produces a single tone. Freenove solution for using buzzers was too complicated and messy for my taste, so instead I chose to use this simpler and more convenient active buzzer module. And yes, there's an affiliate link for these in the description.
Get out of here.
That's right.
One last thing to consider is what happens when we run out of gifts. Whichever method we use to determine if that's the case, the concern is that we don't want the motor to run indefinitely. In this example, the machine gives itself 10 seconds for the gift to be released. If a release isn't detected in time, it will stop the motor and lock the machine, preventing further actions. I've added a red button to the circuit, which will reset and unlock the machine when pressed. This episode wasn't just about making progress, but overcoming fears. Thinking about what I wanted to accomplish and dividing the functionality into small, manageable tasks made all the difference, greatly helped by the Freenove starter kit. Most importantly, I had the opportunity to make mistakes without anything blowing up or releasing magic smoke. With that said, the work on electronics isn't over. More advanced functionality will be necessary. For example, a bigger motor is required for the final product, along with a solution for powering both the motor and Pico. There's a lot more to do on this project, and you can help by becoming a patron or by checking out the links in the description. At the very least, give these videos a free thumbs up. Until next time, this is Silent Mode, maker, artist and LEGO enthusiast, encouraging you all to do your thing.